Here's a second example graphing a higher order polynomial. We have a function f of x equals 3x to the fourth minus 4x cubed. We're going to start with the degree. The degree of this polynomial is 4. So the shape of this graph is going to be either a W or an M. It's called a quartic function. So our degree is 4 in the leading coefficient test, which means it's even. Now let's focus on the leading coefficient of a positive 3. So that tells us that the leading coefficient is greater than 0. So our end behavior is it's going to rise on the right and rise on the left. So think about that like as a quadratic function. Even, leading coefficient positive, opens up. So we know now the shape of this graph is going to be a W. It's going to look something like this. It's going to rise on the right and left. So here's our left, here's our right, and then something's going to happen here. I'm not sure what exactly this is going to look like. So let's start off. Step 2 is to find the zeros of the function. Those will be our x-intercepts. So our function is f of x equals 3x to the fourth minus 4x cubed. We set that blue function equal to 0 and we solve for x. We're going to factor out an x cubed, that's your GCF, and you're left with 3x minus 4. Then we set the factors equal to 0 and solve for x. So I have x cubed equals 0 and 3x minus 4 equals 0. Notice there's a repeated 0 here. The multiplicity is odd, which tells us it's going to cross the x-axis. The second equation I solve for x, so I'm going to add 4 to both sides and then divide both sides by 3. So there's my 0. I'm just going to change that to 1.3 repeating. Identify our x-intercepts next in step 3. So we found an x-intercept at 0, 0. That one was where the repeated happened. The multiplicity was odd, so it crosses the x-axis. The other x-intercept is at 1.3, 0. Step 4 is to graph those x-intercepts. I'm going to just change my scale a little bit to stretch out. So on my x-axis, I'll go by 2. And on my y-axis, I'll go by 2. So this would be by 1/2. 3, 4, 5. 1, 2, 3, 4, 5. All right, so x-intercept. We found an x-intercept right here of 0, 0. Remember, that crosses the x-axis. Then I found another x-intercept at 1.3. So that's about here. Now I talk about my end behavior. My end behavior says I'm going to rise on the right and rise on the left. So my right-hand x-intercept is the red one, and my left-hand x-intercept is my blue one. Now I know the shape of this graph has to be looking like a W. So I want to find out what happens in between here. So now I have to evaluate the function between 0 and 1.3. So maybe something like let x equal 1, and maybe let x equal 0.5 to find out what's happening between that interval. So we're going to evaluate the function for the blue function right here, 3x to the 4th minus 4x cubed. So let's start off with f of 1. So I'm replacing those x's with 1 to find out what the ordered pair is. So 1 times 1 times 1 times 1 is 1. 4 times 1 times 1 times 1 is 1. 3 minus 4 is negative 1. So the ordered pair is 1, negative 1. So over 1, down 1. Then, evaluated for 0.5. So 3.5 to the 4th minus 4.5 cubed. Recommend you use your calculator for that. Let me just grab one. .5 raised to the 4th, then multiplying that by 3, we get 0.1875. 0.5 raised to the 3rd times 4 is 0.5. 0.1875 minus 0.5 is negative 0.3125. So that ordered pair then is over a half, down a third. And that would be this black ordered pair here. So it looks something like that. It's not a symmetric W, but that's fine.